As our planet's ancient ice vanishes, humanity is facing a really profound choice. On the one hand, you've got scientists racing to preserve its memory, to archive the priceless history that's locked inside. But on the other hand, some are asking a much more radical question. Should we actually intervene and try to engineer its future? This is really a tale of two ices.
This quote from Jerome Chappell as wow, it just perfectly captures the urgency, doesn't it? For glaciologists, this isn't just about ice, it's about seeing their life's work, this fundamental record of our planet disappearing right before their very eyes. You can feel that deep sense of responsibility they have to save what they can before it's all gone for good.
So you might be asking, why is this ice so important? Well, think of it like this. Each layer of ice is like a page in a history book, trapped inside of these tiny air bubbles and chemical traces that can tell us exactly what the atmosphere and the environment were like hundreds, even thousands of years ago. By reading these ice cores, we can piece together centuries of climate history. Losing them means we're basically losing the story of our planet.
Okay, so that brings us to our first group of people in this story, the archivists. These are the scientists who are on this incredibly urgent mission, not to stop the melting, but to salvage the knowledge from the ice before it all melts away.
The Ice Memory Foundation has one of the most ambitious plans I've ever heard of. They travel to the world's most vulnerable glaciers to drill out these precious ice cores. And then, get this, the goal is to transport them to the coldest, most stable place on Earth, Antarctica, to create a global library of ice. It's like a sanctuary where this climate data can be kept safe for future scientists to study.
But this is not some simple task. A recent expedition in Svalbard really shows just how difficult it's become. The very climate change they're trying to document was fighting them every single step of the way. First, they faced this brutal, unexpected cold. And then, the ultimate paradox. A huge underground reservoir of meltwater flooded their borehole and broke their equipment. The planet is literally melting under their feet as they try to save its memory.
But despite all those challenges, the team actually succeeded. They managed to extract cores that could hold up to 300 years of climate history. That's just an incredible achievement, and it's a real testament to their dedication. But, this frantic race to remember has led other people to ask a very different kind of question. And this is where our story takes a huge turn. If saving the memory of the ice is this difficult, what about saving the ice itself? This question takes us from the world of archiving to the far more controversial idea of active intervention.
So the term for this is geoengineering. The Royal Society defines it as the deliberate, large-scale manipulation of the planetary environment. The key word there is deliberate. This isn't just about cutting our emissions. It's about actively changing Earth's systems to fight back against climate change.
Now, it's really important to get that not all geoengineering is the same. You've got the global scale stuff like solar geoengineering, which would try to cool the entire planet and would need pretty much everyone on board to agree to it. But then there's this newer idea, targeted geoengineering. This is all about smaller, regional fixes that might only need a few countries to sign off. And this is where the ice comes right back into the picture.
So let's meet our second group, the engineers. They're the ones looking at these targeted geoengineering ideas specifically to protect Earth's most vulnerable ice.
And the ideas being thrown around are on a massive scale. I mean, we're talking about physically blocking ice from flowing into the ocean. We're trying to engineer more snowfall to build glaciers back up. Some are even talking about transforming the entire Arctic landscape to stop permafrost from thawing. There are even plans to try and make sea ice more reflective to bounce sunlight back into space.
Okay, so out of all these wild-sounding plans, scientists believe that focusing on the West Antarctic ice sheet is maybe the most efficient and viable option. This is a spot where a targeted intervention could have the biggest possible impact on a huge global problem like sea level rise.
And remember that small number of states idea we just talked about? Well, for Antarctica, any project like this would fall under the Antarctic Treaty. That means only 29 nations would need to agree. Now, that's still a massive diplomatic challenge for sure, but it's a world away from needing a full global consensus.
So this brings the two threads of our story right back together. We have these two parallel paths unfolding in front of us, one focused on desperately preserving the past, the other on radically engineering the future. It really does put us at a true crossroads.
The archivists, like Ice Memories director Anne Catherine Ullman, remind us what's at stake. If we lose these ice archives, we lose the context for our current crisis. We're basically tying the hands of future generations who are going to need that data to make huge decisions for all of society.
Usually, the default response to something like geoengineering is the precautionary approach. Don't do something if you're not sure of the consequences. But here's the fascinating counterargument. With irreversible climate tipping points on the horizon, what if doing nothing is actually the riskiest path of all? Could a carefully targeted intervention actually be the most cautious choice to prevent a change that can never, ever be undone?
And that leaves us with the ultimate question. As the ice melts, what is our role here? Are we the dedicated librarians, working tirelessly to save the last books from a burning library? Or do we become the engineers, attempting to rewrite the planet's operating system on the fly? The path we choose is going to define our relationship with the Earth for generations to come.